Hey guys, Assalamu alaikum. We are back with ionic bonding now. We have practiced few of the ionic compounds in the previous class. Today we are going to look into the properties associated with ionic compounds. Number one is, I'm writing here the heading first of all, properties of ionic compounds. Number one thing which you should know is this, that ionic compounds have a high melting point and a high boiling point. Whenever we are talking about a solid at room temperature, we should tell that its melting point is higher or lower. So here we should not mention about its boiling point. We can definitely mention about its boiling point as well. But when a compound has a high melting point, it is giving a confirmation that it will have a high boiling point as well. There is a story behind its high melting point in case of ionic compounds. All ionic compounds have high melting point, and why it is so? Due to strong electrostatic forces of attractions. Whenever there are two different type of charges, we can say this thing that they have high electrostatic forces of attractions. Okay, so this you should know that in case of ionic compounds, high melting point due to strong electrostatic forces of attraction among positively charged ions and negatively charged ions. So this is point number one. Number two, they are soluble in water. Okay. Number three, they can, this is very important point, they can conduct electricity in the molten state or in aqueous state. I mean to say solution form. Here is the explanation. In the solid state, actually, ionic compounds can never conduct electricity. And why? In the solid state, the positively charged and negatively charged ions are holding each other tightly due to strong electrostatic force attractions, due to unavailability of mobile ions. In case of the solid state, ionic compound cannot conduct electricity. But in case of molten state or in case of solution form, as ions are free, as lattice of ionic structure is free, is broken, ions are free to move. That's why an ionic compound can conduct electricity both in the molten state and in the aqueous solution. Okay, so this is the story behind that. In here I'm writing in solid state, arrow, no mobile ions. Here, no electricity conduction. Okay, in molten state and in solution form, ionic lattice of ionic compound breaks to make ions free. Hence, ions are available for conduction. A very clear story, okay? A very clear story that in case of the solution form and in case of this molten state, as ions are mobile, as ions are free, that's why they can conduct electricity. Now, there is a word called lattice. So, what is lattice basically? Here I'm writing lattice is a regular repeated layer of ions, or you may say particles. These particles can be atoms, these particles can be ions. So this is a regular layer like arrangement, okay? So a regular layer, regular repeated layer of ions or particles is called a lattice. So basically, it's a three-dimensional diagram, 3D, or you may say three-dimensional diagram for ionic compounds. So we have just studied the physical properties of the ionic compounds on the previous page. It is a diagram like this. So this is a cube. Okay. So this is this, all right, this, okay, and this, all right. So for example, this is the structure of NaCl. So this is Na over here plus Cl over here negative, then Na plus, then Cl negative. Look, oppositely charged ions are associating with each other, are attaching with each other. Na is not attaching with Na. Please be careful. So this is negative and this is positive again. And this is negative and this is positive again. Basically, 6 sodium ions are surrounded by 6 chloride ions, or you may say this thing that basically each of the sodium ion is surrounded by 6 chloride ions, and then each of the chloride ion is surrounded by 6 sodium ions. So this is a three-dimensional diagram which we cannot draw it over here, but this diagram, this cubic structure, this lattice structure will be asked from you in the exam as well. So you are supposed to know this thing, that how to draw this structure, and you can draw the same structure for magnesium oxide. For example, over there magnesium will be 2 positive, whereas oxide will be 2 negative. So you have to draw the structure like this for magnesium oxide as well. You should know this thing, that how to draw the structure for this type of ionic compound. So in today's lecture, we have studied about the physical properties of the ionic compounds, and we have studied how to draw the lattice structure of ionic compounds, as well as what is the definition of a lattice. So in the next class, I am going to discuss about the next type of the bonding, which is called covalent bonding. Thank you very much. Take care of yourselves. See you all in the next class.